Here we have a 12-pole, 3-phase, 60 hertz, one-rotor induction motor, 7.5% slip at full load. Find the full load speed. Remember, the full load speed would be the rated speed of the machine. This one is a rim, and so you see the slip is a bit high, and that's common for one-rotor machines. I'll start off here with, remember, P is 12 poles per phase if it simply says it's a 12-pole motor. And so that is the interpretation that you should use every time, right? Okay, so we want to calculate N, and N shows up in two formulas. Well, that's not really true, is it? NS shows up in two formulas. N shows up only in the slip formula. So we'll start off by calculating NS, and we have 120 F divided by P. And so when it's 60 hertz, you see that number on the top. You get used to that being 7,200 after a while, right? And so, you know, you get a bit of practice at this. You don't bother with that calculation. You notice that's 7,200, and you divide that by the poles per phase, and that gives you the field speed. And in this case, the field speed is 600 RPM. Now, there's a couple of ways now to start this. You notice that it slips by 7.5%, and that's 7.5% of this number, right? And so right there, you can, if you can see through that, you can come up with an equation for N. But our equation for N is going to come from the slip formula, and so NS minus N divided by NS. Now, you know, the algebra becomes a bit easier if we leave out the times 100% and just assumes that we can write slip as a decimal. However, you know, is always defined in percent. Okay, so for this one now, remember that, and so algebra tells us that there's a 1 under here, and we can cross multiply, right? And so therefore, S times NS is equal to NS minus N, and we want to solve for N. So we bring in to the left side, and then we have NS subtract S times NS. Now NS is a common factor, we want to take it out, so N is equal to NS outside of 1 minus the slip. And so you may have already visualized that. If we think about it, slips 7.5% of this number, and you know, 0.075 times 600 give it a slip speed, and then you can figure it in, right? Because we know that the slip speed is NS minus N, of course. Okay, so let's think about this equation. Do we have the information? Yes, we do. And so N now is equal to 600 outside of 1 minus the slip, and again we want to write it as a decimal, so 0.075. And the basic idea is that if you do the algebra first, this is an equation now that, you know, if you write that on your formula sheet, that's something you can refer back to and use without the manipulation, because you got that, right? In any event now, if it slips at 7.5%, then it runs at 1 minus 0.075, which is 0.925, or runs at 92.5% of the sync speed, right? And so the running speed in is equal to 555 RPM. And so I'm wondering now, looking at that, is that 555.5 repeating? Because if it is, I should have rounded it up.